So if you see what we have in this results, you can see all organ meats are rich in vitamin B12, which is same thing with what we have. So it actually says specific organ meats, liver, kidney, hearts, brain, and tribes. Now, so it went further to talk about cholesterol. Now look at this, which is from here. Hello, welcome back to my YouTube channel. So in today's video, I'm going to show you how you can build a PDF RAG chatbot using LangChain, OpenAI, and Streamlit. So I'm going to walk you through step-by-step process on how you can achieve this solution. From our screen, we can see the architectural diagram. So from this architectural diagram, it actually highlights each stage of our RAG pipeline. So from the beginning, you can see the documents. Then we're using the Unstructured to extract both tables and text. And from here, you can see the large language model, so which is the OpenAI, and we're using the GPT-4 model. So we're passing it through the GPT-4 model. And what we did here is just like we take a summary of both the text and the table, which is what you can see inside this box. So after we've taken the summary, we are going to put them in a vector store. So the vector store we're going to be using is PGVector. And the PGVector is actually like an extension for PostgreSQL. And this is where we're going to put all our vector embeddings. So if you can see the summary, we're passing it through the multi-vector retriever. And as well, we have the raw text and tables. So these raw text and tables, they are going to be put in a document store. So the document store which we're going to be using is Redis. So if you can see from here, we have the multi-vector retriever, which has both the summary and the raw PDF. So we are passing this raw PDF, which is the result of the multi-vector retriever, is what we have as our context, which is what we are going to send to our large language model before we actually get our response, which is the final output. So we've seen what the architectural diagram entails, and we're going to go to the code and we're going to implement all this process. So before that, we also need to do some installation because the installation is actually very necessary before we go to the coding. So the things that we need to install, we have the Poplar. So we can see the Poplar, and we also need to install the Tesseract. So, but if you have any problem installing both Poplar and Tesseract on your Windows machine, there's a video which I already created earlier, which is for that. I'm going to attach the link, so you can see how you can import both Poplar and Tesseract on your Windows machine. So, and we are also going to install a requirement file, and I'm going to show you how the list of things when we go to the code aspects, and you see the things that we need to install. So also we need to get our API key from OpenAI. So we set up an API key, which is what we're going to use to communicate with OpenAI. So we are going to put this in an environment variable. So we're also going to do that. And again, we need to create a Postgres database, which is for our PGVector. So here we are using Docker to do that, which is what you can see in this image below. So I'm using Docker to actually create the database with PGVector running inside the container. So which is you set up PGVector from the image. And the last one is our Redis server. So how we can set it up is actually also in the image. So now we are going to go to the coding where I show you how the list of things are installed. So before we go to our Jupyter notebook. So in our directory, I'm going to explain all the list of things that we have here. So first and foremost, let's look at the requirement.txt. So the requirement.txt has the list of things that we need to install. And this list came from, so let me open this. So this list came from this LangChain community. So those are the things that we actually installed, which make up what we have in the requirement.txt. So these are the things that we installed, which we have in the requirement.txt. And again, I'm installing unstructured or docs. So the reason why I'm doing that is, let's say I want to work with PDF, CSV, and every other thing later. So that's why I installed all docs. So you can decide to install just for PDF alone, but installing the all docs is the reason why we have so much things inside this requirement.txt. And again, under this git pod, so I'm running this particular code under git pod. So whenever I open my repository with Gitbot. So I mean my GitHub repository with Gitbot. So it's going to install all this list of things automatically. So you can see everything that I mentioned earlier. Remember I mentioned Poplar, I mentioned Tesseract. So here is where I'm actually installing the requirements too. So I just put everything in this gitbot.yml, which is to install everything whenever you open it with Gitbot. So you see the Docker, you see the you see the Redis and the others. So I'm going to attach the link to this repository under the description so you can see everything that I mentioned. So again, I'm going to show you the data which we are going to use to demonstrate. So I'm going to use one of these data to demonstrate. And there is a database.py which I created. So this database.py is just for me to create a connection string to PGVector. So why I define the user, host, password, So I'm going to use this connection string and the collection name. So those are the two things which I'm going to use inside my Jupyter notebook. So I'm going to go to the Jupyter notebook now since I've showed you the installation and everything. Okay, one thing again. So one thing again is the env, so which I haven't created. So I just need to add the OpenAI API key. Yeah. So, okay. Let me just close this. Yeah. So first and foremost, we need to import a library. So I'm going to run this cell. Okay. So I'm also going to load the env. Okay, so this is the 5 parts to the data which I want to work with. So I already defined the 5 parts. So the next thing we're going to do is we are going to load our data. So this is where we are going to do the extraction of the tables and text. And the unstructured library actually helps us to chunk the information that we have in both tables and text. So I'm going to explain everything. So if you look at here, we have the partition PDF. So this is a function from unstructured library. So we are taking the partition PDF from unstructured library. So where we pass in our 5 parts and we pass in infer table structure. So these parameters, they're actually very important. So when I use infer table structure, it's just telling me like I want to extract tables. So it's very important for me to specify that in my code. And this is actually not what I need for this code because I'm not working with images. So assuming I'm working with images, these parameters, they are very important as well. So the next thing is the chunking strategy. So I'm going to define my chunking strategy by title. So the reason why I'm doing chunking strategy by title is because we have headings and we have subheadings. So I'm going to explain that. So if you look at what I have here, I have an heading which is this. Then I have a subheading under it, so which is under the major heading. So I believe there will be another subheading below, maybe 2.2. So this is just telling us like all these subheadings, they are actually under the main heading. So we're just trying to tell, using this partition PDF, we are trying to tell you like we want it to chunk by the title. So everything that I showed you earlier, which is the subheading, they are going to be under the main heading. So they are not going to be separated. So that's just the meaning of chunking strategy by title. So, and I also have the maximum character. So this is how we actually chunked. So this is also very necessary that we specify that. So this is also not required for this scope because we are not dealing with image. So I'm going to run this function and I'm going to call it. Okay, so I'm going to check the result that actually came from there. So I'm going to print the PDF elements. So these are the list of things that we just extracted. So we have the table element. You can see the table, and we have the composite elements, which actually stand for each of those texts. So we have the tables and we have the text. So what we are going to do now is from this result, we are going to separate both the tables and the text. So I'm going to check through these composite elements. whereby I get all the text information from the composite elements, and the tables, I'm going to get them as HTML. So I'm going to explain that, what I mean by getting it at it as HTML. So this is where we actually do that. So we are going to look through the PDF elements. So we look for the table. So we check for the type of the table. So we said if table in the type, which is we are trying to get the table, and the same thing for the composite elements. So how we get the HTML list, there's something they call metadata. So we are going to take one of these. So which is we are going to take the PDF elements, then we're going to take one, so which is one of the list in the result. Then we're going to do dot metadata. So the metadata is just like how we can see more information about each of these composite elements. So it actually has something they call original elements. So if I take this from dict, so, and I try to look at this original elements. So the original elements actually gives me information of everything that I have inside that composite element. So you remember I mentioned like I want to get the composite elements in text, and those for tables I want to get it as HTML. So I'm going to use the metadata to get that. So to do it, so you can see where I'm looping. So I'm going to do for the table, I'm going to do dot text as HTML. So through the metadata, you can do that. And for text, you might use the dot text straight away because it is, you already checked through the composite element. So if I run this cell, so I'm going to have both my tables and text. So let me print that. So you will see the table. So these are the list of tables that we have in this PDF. And if we check the test, so let's check the test too. So these are the list of text from the PDF. So you can see like this has actually been chunked using the unstructured library. So we have the tables and we have the text. So again, let me display one of the tables. So let's just see how the table look like. So we can use the IPython to display that. So I use the display from IPython. So I can print this, so which actually shows me how the table looks like. So which is what we can see here. So now remember we have grouped the tables and text to different boxes. So we're going to send this information to a large language model, which is what we specified when we were explaining the architectural diagram. So we need to do a summary of all this information. Doing the summary is actually very important before we convert them to embeddings. So we're going to summarize this information, which is the text and tables. So this is where we are summarizing the data. If you look at this function, the first thing is I define the prompt text. So just like I'm telling the assistant what I expect it to do. So this prompt text actually guides the large language model on what it's going to do. And for this summary, I'm using GPT-4 mini to do the summary, but actually you can use any other, any other model you prefer to do the summary. It doesn't have to be GPT model. So if you look at the prompt text, we are passing it through the chat prompt templates, and we have our model, which is the GPT-4 mini, and this is where we actually pass in the query which we want to summarize. So we are using the runnable pass-through to do that, and we chain it to the prompt. Then the result of the prompt is passed to the model, and result of the model is passed to our string output parser, which is we want the information to come out in a very neat manner. So that's the meaning of the string output parser. So after that, let me take out these logins. So what we did after that, sorry. So after we've done that, we've defined our chain, which is we've sent the information from the prompt to the model, then to the parser. So we're going to invoke, but we are using the batch. So I just said invoke because when you send a query, most times we use invoke, but we're going to use the dot batch method. So which is we use the chain, which is the summarized chain, then we do dot batch, which means we want to send like multiples of our text at once. And we also want to send multiples of our tables at once to summarize. So I'm going to run this function. Okay, so I'm going to call it where I have the data summary. So I'm going to check through the information from the results. So we'll have everything that we need. So we have the text and we have the tables. So what we're going to do is I'm just going to define these texts and summaries. I'm going to say text summary is equal to, so just take from the dictionary. Let me take out the text. So I define text summary. So I'm going to define tables summary. So table. So which is, I'm taking the key of the dictionary which we use to export the results. So this is the table as well. So which is what I did. I just put them in different variables. Okay, so now we have our text summary and we have our table summary. So the next thing we need to do is we are going to put this in our PGVector. And before we can put this in our PGVector, we need to actually create an embeddings for this. So we are going to create an embeddings using OpenAI. Then we are going to put this in a vector store, which we are using PGVector. So what we are going to do is I'm just going to create an initialization. So I'm not storing the information yet. So just to create an initialization where I pass in you can see the RedisStore where I have the client, and PGVector where I pass in the OpenAI embedding. So I'm using the connection string and the collection name for PGVector here as well. So then this is to initialize. So I have the multi-vector retriever here, then I pass in the vector store and the document store. So then after I've done this, just like I'm just trying to create like a retrieval loader. So I'm going to use this later where I'm going to add the documents. So now after I've done that, this is where I actually had those information inside the vector store. So you can see from here, I'm defining the document IDs. So this document ID was actually created like a unique identifier, which I'm going to explain. So we have the summary document. So what the summary document is doing is just like we are trying to create a document. Every information that we have from the summary that we got, we want to create them as a document. In LangChain, we have a document loader. So here we are trying to use the document loader formats. We are going to pass in a summary and we are going to create a metadata. So the metadata actually helps for indexing. So here we are passing the key, which is the unique identifier from here to the document which we are trying to create. And if you look at here, we are using the retriever. So we had the documents here. So this is where we had the summary. And this is where we had the raw PDF that we mentioned. So the raw PDF is going to the store and the summary is going to the vector store. So if you look at the function, you can see where we pass in the text summary, table summary. So this is where we're actually doing that in this code. So the ID was created for retrieval purpose. So I'm going to run this and I'm going to run this. So where I have my retriever. So this is the query I'm going to use for the retriever. So I'm going to invoke. So I'm just going to ask the question, which is what is the comparison of composition of red meat, vegetarian, protein, sources. So I'm going to use this retriever and invoke based on this query. So I'm going to run this. Then let's check the results. Let's see. Yeah, so our retriever actually gives us some information. So if I look at here, we have these average values from 2022, So those are the results which came from the retriever. So now the next step is we are going to use this retriever. Remember, we've created the retriever. So this retriever is going to serve as the context which our large language model will work with. So that is the next thing we need to do. So we're going to send the retriever. So any information that came from the retriever will serve as the context to our large language model. So first thing first, so what we need to do here is we need to clean up the results from the retriever. So it's just like if we have any bytes information from there, we want them to be decoded as strings. So this is what this is doing. And if you look at the function below, so we have this chat with LLM. So this is actually where we send the context to our large language model. So we're going to send our query, which is what the user is asking, and the large language model is going to work with the context that is coming from the retriever to answer the query. So now, if you look at what we did here, we have the prompt text. So it's just like we define a context and we define a question. So this question is what we are going to be sending. And we have the chat prompt template, just like what we defined then. And we have chat OpenAI. So if you look at the context, you can see this is for the retriever. And remember what I mentioned here about this parser retriever output. So I'm going to use runnable lambda to execute that function. So which is what I'm doing here. And you can see this chain. This chain is just trying to tell me like the outputs coming from the retrieval is being sent to the runnable lambda to execute the function above. So the result from here is going to the parser retrieval output, which is the runnable lambda. We execute that. So again, we have the question, which is our user question, which you are going to send through the runnable pass-through. So both the context and the question, any result coming from there, so it's going to go to the prompts, which is here. And the reason why we actually created this runnable pass-through.assign is just like we want to create like a key, which is like a response. We want to create a new key. So we're going to create a new key for response, and we're going to have context in our result as well. So we're going to see context, question, and the response. So the results coming from the context and question is going to be passed to the prompt, and from the prompt to the model, and from the model to the string output parser. So we're going to run this function, and I'm going to call the function here. Something is wrong. Let me check that. Okay, I haven't run this function yet. So I'm going to run that. Then let's run it again. Okay, so now we're going to ask question from our large language model, which we expect it to work with the context to answer our question. So I'm going to send this question. I said, what is the nutrient composition of beef, veal, and this? So let me see the response, which is going to generate. Okay, so I'm going to check the response. Yeah, so this is what my response looks like. So you can see the context, and this is my question, and this is the response. So, and I'm going to check the response of this large language model. So let me see if it's doing what I expect it to do. So let's check. Okay, I think I should do print. Yeah, so this is the results coming from the large language model. This is actually a table. So it said the nutrient composition for per 100 gram is this, okay, which looks good. And I could actually ask more question. Okay, let me run this cell. So if I check the response, so let me just check the response. So it's saying what is defined by the food standard. So now we've seen everything by which we created our rack pipeline, and we've been able to do everything that we mentioned from our architectural diagram. So one thing we need to do next is we are going to create this solution with Streamlit, and I'm going to show you how I did that by creating the solution using Streamlit. So okay, so this is the Python file where I have the Streamlit code. Then it's just like I take everything that I have from the Jupyter notebook. I just had some few functions to hit. So this is why I actually import all the library, and I'm going to explain everything. So here I'm just trying to set my PyTorch module, then this is the Redis clients, and I define the logins here. So okay, so remember we have load PDF data, which is what we have from our Jupyter notebook. So this is what we actually took here. And again, the next thing that we have, which is the function, which is get pdf hash. So the reason why we actually define this get pdf hash is just to enable us to just to identify each pdf that we have. So the reason is just that if I upload a new pdf, my application should be able to recognize like this is a new pdf, or if I already have something that is in existence, so it should recognize that. So I'm generating a unique hash for each PDF file. So also the next function we have here is how to summarize the text and tables. So this is the function, so which is what we've used previously. And we have the initialize retrieval function. Okay, so also the store text and table, in vector store and document store, that's that. So we've seen this before. So where we are passing the retrieval outputs, and the chat with LLM function, which we've seen previously. And okay, so the next one here is just to get file paths. So here we are trying to generate a temporary file path for all the uploaded documents. So whenever we upload a document using Streamlit, we just want to create like a temporary file path, whereby this path is what we are going to send to our partition PDF function. Okay, so the next thing is, this is where we actually process all the entire information. So all the functions that we have previously, we just call them here. So this is where we have the file paths. So where we generate temporary file paths, and the PDF hash, which I mentioned earlier. So this is where it is. So the PDF hash is what we actually use to check each PDF. So if I've uploaded a previous PDF, it's going to check it, and then what it's just going to do is, I have all those information in my vector store and redis store. I remember like redis store that I'm using is for persistent storage, so which is the reason why I'm using that. So the only thing I just want you to do is just to load those information, and I use the retriever to get the results. So I don't need to go through all the chunking, summarizing, and everything all over again, because the PDF documents I've used that previously. So which is what I'm using with the PDF hash. So if I'm able to generate the PDF hash, so I just load the retriever here, then I use the client.exist, which is to check for the hash which we generated. So if it actually exists, so it is just going to load the retriever. So if the PDF hash doesn't exist, so this is what we do. So we just call the previous function. So here we are getting the tables and text, then we summarize, we just return the retriever. Okay, so this is where we actually invoke the chat. So we're trying to call the chat with LLM. So we use the retriever, we pass in the retriever to our function, which is chat with LLM, where we send the retriever as a context. And this is where we send in our message. So this message is what we are going to send through the chat whenever we send anything from Streamlit. And Streamlit is going to append our response here. Okay, so the main application here is just to define a title and the logins. So this is for Streamlit, and here is a session state, which is also for Streamlit. So this is where we define the file upload for Streamlit, which is where we actually upload the file. And here it checks if the file has been uploaded, and from here it takes the user input. So anything I send through the Streamlit, this is where it's taking it, and again this is where it's actually writing the message on the screen, anything I sent. So this is where it's writing the message on the screen. So everything I have here is for the assistant. So this is where it actually generates the response, from the large language model, and it is writing the response back to us. So I'm going to run this code. So I'm going to run this Streamlit code so we can see everything which I've mentioned. So we are going to do Streamlit, then run. So the name of the file. So let's open browser. So I'm going to upload a file here. So I'm going to upload this file. So what is the nutrient composition of organ meats? So, okay. So it's actually give us some information, which is nutrient composition of organ meat. So it said general characteristics, specific organ meats. So we're going to go back to the PDF and see if what it actually gave is correct. So if you see what we have in this results, you can see all organ meats are rich in vitamin B12, which is same thing with what we have. So it actually says specific organ meats, liver, kidney, hearts, brain, and tribes. So it went further to talk about cholesterol. Now look at this, which is from here. So this actually looks cool, and we can ask more question. You know, we can ask more question from this large language model. So let me ask this. So can you tell me what is can you tell me the nutrients of lean red meats? Okay, so let's send this. So this is actually what we got from our question. So we said nutrient composition of lean red meats. So now it's returned something, both flavin, phosphorus. So we can check what is here. It's actually inside, which is from this particular PDF, and we can go further to ask as many questions as possible. No, we can ask as many questions. So okay, I can ask okay, let me ask this. What does raw red meat mussel contains? Yeah, look at this. Raw red meat contains 20 to 25 per 100 gram, which is actually what we can see in our PDF. So you can keep asking more questions, but remember the persistent storage which we created, that's the reason why we were able to keep sending this question and we were able to generate our answers, because it doesn't have to go all the way to start chunking from the beginning. Since it just takes the vectors, then the retriever is sent through the contents of the retriever is sent to a large language model and we have a response. So this is the end of this video. Hope you found this video helpful. If you have any question, please drop them below. Also, please give me a thumbs up, subscribe to my channel so you can get related content like this. Thanks for watching. I would love to see you next time.